Hello, and welcome to this lesson on the current atmosphere. In today's lesson, we will understand the current composition of the Earth's atmosphere. We will then explore its stability over the past 200 million years. Finally, we will understand the limitations in studying the early atmosphere. To fully understand the current composition of the Earth's atmosphere and its stability over the past 200 million years, we need to look at the precise proportions of the various gases and their roles. Let's break it down step by step. Nearly 80% of the Earth's atmosphere is made up of nitrogen gas. Nitrogen is essential for life as it is a major component of amino acids and proteins. Despite its abundance, nitrogen gas is relatively inert and does not easily react with other chemicals in the atmosphere under normal conditions. This high stability is one reason why nitrogen has remained consistent in the atmosphere for millions of years. Oxygen makes up about 20% of the atmosphere. It is crucial for the process of respiration carried out by most living organisms. Oxygen is more reactive than nitrogen and forms compounds with many other elements. The presence of oxygen has also enabled the formation of the ozone layer, which protects the Earth from harmful ultraviolet rays. Despite oxygen's reactivity, its proportion in the atmosphere has remained relatively stable due to the balance between processes like photosynthesis, which produces oxygen, and respiration and combustion, which consumes oxygen. Argon, a noble gas, constitutes about 0.93% of the Earth's atmosphere. Being a noble gas, argon is extremely stable and inert, meaning it does not readily react with other elements or compounds. Like with nitrogen, this stability contributes to the overall consistency of the atmosphere's composition. Carbon dioxide is present in much smaller quantities, approximately 0.04%. Despite its low concentration, CO2 plays a significant role in the Earth's greenhouse effect, trapping heat and keeping the planet warm. As with oxygen, natural processes like photosynthesis, where plants absorb CO2, and respiration, where organisms release CO2, help to maintain its levels. Other gases such as neon, helium, methane, krypton, and hydrogen are present in even smaller amounts. Water vapor, H2O, is also a critical component of the atmosphere, varying significantly in concentration depending on location and weather conditions. These trace gases, while present in minute amounts, can have significant impacts on climate and atmospheric chemistry. Let's now turn to exploring the stability of the Earth's atmosphere over the past 200 million years in more detail. The relatively stable composition of the atmosphere has been maintained due to the balance of various natural cycles. These include, in the carbon cycle, CO2 is cycled between the atmosphere, oceans, plants, and animals. Photosynthesis and respiration are key processes in this cycle. The nitrogen cycle occurs as follows. Nitrogen is converted into various chemical forms as it circulates among the atmosphere, terrestrial, and marine ecosystems through nitrogen fixation, nitrification, and denitrification. In the oxygen cycle, oxygen production via photosynthesis and consumption through respiration and oxidation processes keep the levels of O2 stable over time. So, what about the time period prior to the past 200 million years? After all, the Earth is estimated to be about 4.6 billion years old. What happened in the 4.4 billion years before? When studying the Earth's early atmosphere, this is a big limitation, as it gives rise to a lot of uncertainty regarding the early atmosphere. We don't have early atmospheric samples or other concrete ways of confirming theories. However, many theories have been developed based on evidence such as volcanic activity and composition of very old rocks. Such theories will be the focus of coming lessons. In today's lesson, we delved into the current composition of the Earth's atmosphere and its stability over the past 200 million years. We examined the precise proportions of the main gases: nitrogen, approximately 80%, oxygen, about 20%, argon, 0.93%, and carbon dioxide, 0.04%, along with trace gases like neon, helium, and methane. We discussed the essential roles these gases play and highlighted the stable nature of noble gases like argon, as well as the role of trace gases. Furthermore, we explored the natural cycles that maintain the atmospheric balance. Finally, we briefly discussed why there is a lot of uncertainty regarding the Earth's early atmosphere. Watch the rest of the GCSE chemistry course at Sophos Education.